Is consciousness a quantum phenomenon? The relationship between consciousness and the quantum world is a fascinating and complex topic that blends elements of neuroscience, physics, and philosophy. This article delves into the possibility that our awareness is intricately connected to these strange and mysterious laws of quantum mechanics. What is consciousness? Nature of consciousness. Consciousness remains one of the greatest mysteries in science and philosophy. It is the subjective experience of awareness and perception, but understanding its nature has challenged researchers for centuries. When we speak of consciousness, we refer to the quality or state of being aware of an external object or something within oneself. It includes various aspects of being aware, such as feeling, thinking, knowing, and the executive control over attention. Relationship to the brain. Traditionally, consciousness is thought to arise from the complex interactions of neurons within the brain. The study of this relationship has led to numerous theories about how physical processes give rise to conscious experience. For instance, the global workspace theory suggests that consciousness arises from the integration of various neural processes across the brain. Another theory, the integrated information theory (IIT), proposes that consciousness corresponds to the capacity of a system to integrate information. Fundamental property. Some theorists propose that consciousness might be a fundamental aspect of the universe, much like space and time. This view, known as panpsychism, posits that consciousness is a universal feature of all matter. According to this perspective, even the smallest particles in the universe have some form of experience, and consciousness at higher levels, such as in humans, is the result of complex interactions among simpler conscious entities. The quantum world. Quantum mechanics. This field describes the behavior of particles at the smallest scales. Concepts like superposition, particles existing in multiple states simultaneously, entanglement, particles influencing each other instantaneously at a distance, and quantum decoherence, how quantum systems interact with their environments, are key ideas. Quantum mechanics challenges our classical understanding of reality and introduces phenomena that seem counterintuitive and bizarre. Superposition. In the quantum world, particles can exist in multiple states at once. For example, an electron can be in multiple places simultaneously until it is observed or measured. This concept challenges the classical notion of a particle being in a single, definite state at any given time. Entanglement. Quantum entanglement is a phenomenon where particles become interconnected such that the state of one particle instantaneously affects the state of another, no matter the distance between them. This spooky action at a distance, as Einstein called it, suggests a non-local connection between particles. Quantum decoherence. This concept explains how quantum systems lose their quantum behavior and transition to classical behavior when they interact with their environment. Decoherence provides a framework for understanding how the classical world emerges from quantum mechanics. Implications for consciousness. The strange and non-intuitive nature of quantum mechanics has led some to speculate that it might play a role in consciousness. The idea is that the brain, being an incredibly complex system, might leverage quantum processes to produce conscious experiences. This speculation opens up a new frontier in understanding the mind and its connection to the physical world. The quantum consciousness hypothesis. Hypothesis. This idea suggests that quantum processes within the brain could be responsible for consciousness. This is a controversial and speculative area of research. Proponents argue that classical physics cannot fully explain the phenomenon of consciousness, and quantum mechanics might provide the missing pieces of the puzzle. Theories. Several theories propose mechanisms by which quantum processes could contribute to consciousness. Notable among them is the Penrose-Hameroff Orchestrated Objective Reduction, OR model. This theory, proposed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff, suggests that consciousness arises from quantum computations within microtubules, which are structural components of neurons. Orchestrated objective reduction, OR. According to this model, microtubules within neurons can perform quantum computations, and consciousness arises from the collapse of quantum states within these microtubules. The theory suggests that the brain's microtubules are capable of sustaining quantum states, and that the reduction of these states corresponds to conscious experiences. Quantum brain dynamics (QBD). Another approach, known as quantum brain dynamics, posits that quantum field theory can describe brain function. This theory suggests that brain waves and consciousness are related to quantum fields and coherent quantum states in the brain. Challenges. There are significant challenges and criticisms of these theories. One major challenge is the difficulty of experimentally testing the quantum consciousness hypothesis. Quantum processes are incredibly delicate and are typically observed only in highly controlled environments at very low temperatures. The warm, wet, and noisy environment of the brain seems incompatible with the delicate nature of quantum states. Testing and experimental evidence. Experimental verification of quantum consciousness theories is currently beyond our reach. The brain's environment makes it difficult to maintain and observe quantum states, raising questions about the feasibility of these theories. Criticisms. Critics argue that there is no compelling evidence to suggest that quantum processes play a role in consciousness. They point out that classical physics and existing neurobiological models can explain many aspects of brain function and consciousness without invoking quantum mechanics. The complexity of the brain. The brain is an incredibly complex organ, and understanding its workings requires an interdisciplinary approach that integrates insights from neuroscience, psychology, physics, and other fields. The quantum consciousness hypothesis adds another layer of complexity to an already intricate problem. Evidence and arguments. Supporting evidence. Some suggest that phenomena like quantum entanglement could play a role in brain function and consciousness. For instance, it has been proposed that entangled particles might facilitate faster and more efficient information processing in the brain. Additionally, some researchers have observed quantum effects in biological systems, such as photosynthesis and bird navigation, suggesting that quantum processes can occur in warm, biological environments. Photosynthesis and quantum coherence. In photosynthesis, quantum coherence has been observed in the process by which plants and some bacteria convert light into chemical energy. This suggests that quantum processes can play a functional role in biological systems. Bird navigation and quantum entanglement. Certain bird species are believed to use quantum entanglement to sense the Earth's magnetic field for navigation. This phenomenon, known as quantum magnetoreception, provides a biological example of how quantum processes might influence behavior. Limitations and uncertainties. Current scientific understanding of both quantum mechanics and the brain is incomplete, and integrating these fields presents numerous theoretical and practical challenges. The complexity of the brain and the counterintuitive nature of quantum mechanics make it difficult to formulate testable hypotheses and conduct experiments. Incomplete understanding. Our knowledge of quantum mechanics and its implications for macroscopic systems is still evolving. Similarly, neuroscience is a rapidly advancing field, and new discoveries about brain function are continually emerging. Practical challenges. Experimentally probing quantum processes in the brain requires advanced technology and innovative methodologies. The brain's dynamic and complex nature adds to the difficulty of studying potential quantum effects. The future of consciousness research. Ongoing research, scientists and philosophers continue to explore the potential connections between quantum mechanics and consciousness. This includes both theoretical work and experimental research. As technology advances, new techniques may allow researchers to probe the brain at finer scales and with greater precision, potentially uncovering evidence of quantum processes. Theoretical work. Researchers are developing new models and frameworks to understand how quantum mechanics might relate to consciousness. These efforts involve interdisciplinary collaboration between physicists, neuroscientists, and philosophers. Experimental research. Advances in imaging techniques and quantum technology may enable scientists to investigate the brain's quantum aspects more effectively. For example, techniques like quantum tomography and advanced microscopy could provide insights into the brain's quantum properties. Implications. If a quantum basis for consciousness were proven, it could revolutionize our understanding of the mind and the universe. It might lead to new technologies and insights into the nature of reality itself. For instance, quantum computing and quantum communication could benefit from a deeper understanding of the brain's quantum processes. Technological innovations. Discovering quantum processes in the brain could inspire new technologies that leverage quantum principles for advanced computing, secure communication, and other applications. Philosophical implications. A quantum basis for consciousness would challenge our current philosophical perspectives on the mind-body problem, free will, and the nature of reality. It could lead to a paradigm shift in our understanding of existence. Importance of exploration. The quest to understand consciousness is a fundamental part of human inquiry, and continued exploration, open-mindedness, and interdisciplinary collaboration are essential. The intersection of quantum mechanics and consciousness invites us to reconsider the very nature of reality and our place within it. Interdisciplinary collaboration. Understanding consciousness requires input from various fields, including physics, neuroscience, psychology, philosophy, and computer science. Collaborative efforts can yield new insights and foster innovative approaches to research. Open-minded inquiry. Exploring the connections between quantum mechanics and consciousness requires an open-minded approach. Researchers must be willing to entertain unconventional ideas and consider multiple perspectives. Conclusion. The intersection of quantum mechanics and consciousness is a tantalizing frontier, inviting us to reconsider the very nature of reality and our place within it. The journey to unravel these mysteries is just beginning, and the implications of such discoveries could reshape our understanding of the universe and ourselves. While the quantum consciousness hypothesis remains speculative, it opens up new avenues for research and challenges us to think beyond conventional boundaries. As we continue to explore the mysteries of consciousness, it is crucial to remain open to new ideas and approaches. The quest to understand the mind and its connection to the quantum world is a profound and ongoing endeavor that promises to deepen our understanding of both ourselves and the universe. The intersection of quantum mechanics and consciousness challenges us to think beyond conventional boundaries and invites us to reconsider the very nature of reality. The journey to unravel these mysteries is just beginning, and the implications of such discoveries could reshape our understanding of existence itself. In summary, while the quantum consciousness hypothesis remains speculative, it represents an exciting and tantalizing frontier in the study of the mind. Through continued exploration, open-minded inquiry, and interdisciplinary collaboration, we can hope to uncover new insights into the nature of consciousness and its relationship to the quantum world. The pursuit of this knowledge is not only a scientific endeavor but also a philosophical and existential one, as it seeks to answer some of the most profound questions about who we are and our place in the cosmos. This article was converted for free by the courtesy of AudioRead. If you enjoy the service, please consider upgrading your plan to listen to up to 500,000 words per article. Simply go to audioread.com/ad and you'll see the upgrade option. Your support helps us keep making the service better. Thank you.